Hola, buenas tardes a todos, bienvenidos.
Hello and welcome. We're going to talk during this session about 5G robotics supervising industrial environments. My name is Vanesa, Montoya, and together with my friend Alonso, we work in innovation department of Telefónica Spain. So the session will have two parts. We're going to introduce the fundamental 5G leverages, and then we are going to explain how 5G contributes to robotics and allows us to create a new application scenarios. And then we are going to do a live demo. We have Spot Enterprise. It is the robot in Boston Dynamics that you might know. I give the floor to Alex now. Good afternoon. It is a pleasure to be here with you today. I'm Alejandro, Alonso, expert in innovation in Telefónica España. And as my colleague said, before talking about robotics and demo, we want you to understand which are the main levers that we offer in Telefónica in 5G and technologies that facilitates robotics in the future and also the present. The first one, you can see them on the screen, is 5G network. You already know it. This is a network that offers a density of 1 million devices per square kilometers, very high velocities and low latencies in different broadbands. I would like to underline the 700 megahertz that democratizes the 5G networks that we are updating in the Mobile World Congress that complements with the other broadbands in which we need higher capacity. And on the other hand, we have the edge computing technology. It is the edge computing technology. It is regionalizing the content and decreasing the latencies. And then we have network slicing, which is a technology that it is in the avant-garde because it puts together the other two, the 5G network and the edge computing. And we have the 5G network, and we divide it in different sub-networks. So the network adapts to the needs of robotics and not the other way around. So the network grows, it's digitalized, and it's transformed in an exponential way with all these different facilitators. The network is more complex and gives more services. It's adapting to the needs of the customers, and it's important to have this smart layer. We need the networks to be smart, proactive, and programmable, and that they ensure the quality of the service we give to the customers. All these levers that we use have a facilitator that is fully cross-section, that normally is transparent and has to be present. It's a cybersecurity. 5G networks are secure by definition. They authenticate the communications and they cipher these communications with the best cryptography security measures. And the edge computing nodes isolate the communications, and then they improve the cyber security of all this cross-section technology. The network slicing separates the network in different sub-networks, and then you isolate the communications, and it is an additional factor in cyber security. And also when you have this intelligent network, you will be able to prevent any type of cyber security attack, and being proactive and preventive, and then the network will always be protected. So everything I've explained to you can be seen in this slide. We divide 5G network of Telefónica in different sub-networks with a smart intelligence layer with all these different technologies. And we have the first slice, the internet navigation, use of social media, etc. The one in the middle is devoted to robotics. The network is adapted to robotics, to the customer. And then the telecontrol slice with the broadband and the edge computing regions we mentioned with 5G nodes that give a service, a radio service. And in this slide, we are giving a telecontrol service, someone who is controlling a robot 15 or 20 kilometers, and then they can translate, or they and they can translate their eyes there, and then it's like they were there. We will see it in detail during the demo. And then we can have another slide in which we remove the human factor. All the video, audio flows of the robot are sent to a platform in the edge computing that processes at real time all the information and makes decision in autonomous roads. So they show the robot where to go and how to move. With this model that is a training and learning and communicating with the edge area and improving the decisions taken by the robot. So once we have explained these levers, Vanessa is going to explain to you how we can apply them to the robotics. So this 5G is going to foster different scenarios in which we can extract all the potentiality of this last generation robotics. The keys in the 5G in robotics is the low latency, first of all, during time, these communications, and then the possibility to execute software in the cloud, and also create broadband in order to exchange information from the robots towards the network. So with all these aspects, we see different scenarios. First of all, the possibility to telecontrol different robots that are autonomous and they are mobile. A good example would be Sport Enterprise. It is a quadruped robot that can walk. It adapts to surfaces, going upstairs, ramps, and also it incorporates an articulated arm in order to do some operations that require a lot of precision. So thanks to the edge computing, we have some platforms in remote control, keeping this low latency during a lot of time in order to guide these machines in order to do the specific missions. For example, faraway destinations in which we don't have the equipment to do the things on the field. We use this technology to do this basic operation surveillance management. And it is also very interesting when we talk about places in which, depending on the activity, there is a specific risk. And people cannot work there. So we are not exposing them to risks, and these missions are done by these robots. And the other scenario would be the evolution of what we already know, the AGVs systems, robots that can move material from one place to another. And then the 5G technology is going to evolve, and we are going to have multi-robot systems. We are going to have fleets of a lot of robots, all of them very different, with different dynamics. They can be mobile or permanent, and they will all be collaborating and doing a very complex activity, coordinated from the network, and in order to cover the logistics of a factory, for example. So we are going to take these processing systems to the network. We are talking about cloud robotics scenarios. We will be able to execute on the edge and management of the routes that are going to optimize the navigation, and we will also be able to process all the data from the sensors, and we can send this information, we can process this information, and all this data are going to feed these algorithms based on deep learning and machine learning. This way we give these artificial vision capabilities to these robots, or pattern detection, just to give you a few examples. The other scenario I would like to mention is a very interesting one. The cobots, we are talking about robots that collaborate with human beings. It is important to have this rationale that will allow this robot to interact with a human being. So we are talking about systems that react to changes in the environment. So we have some dynamics that we need to assume. And the human behavior is very difficult to predict. So a robot needs to detect our needs and learn how to interpret our emotions. So if these capabilities are done from a network, from a 5G network, we will be able to have a very sophisticated software, flexible software. And this scenario is interesting because it has different applications. We can have a robotic arm collaborating with a person working in a factory, so bringing material, and also new scenarios and applications as service robots. We have the waiter, for example, and we can also have robots that can do accompanying, a social robot applied to education, for example, and healthcare issues. And also going back to the industrial aspect, we would like to give you some examples of possible applications and uses in logistics. For example, robotics is the part of the industrial process that needs this technology. And we have these fleets, and we go towards a scenario of this conscient factory that can manage a lot of information and manage different types of robots, and also covering the last mile delivery with terrestrial or air robots that allow us to deliver a parcel in a specific place. And also this exchange of information is can only be assumed by a 5G network. In Industry 5.0, robotics is a technology fostering innovation towards smart industry. And having a robot that we can control with a number of sensors will allow us to send this information to the point we want and do an assessment, or, for example, collecting information in order to do a reading of a gauge or whatever. And that will allow us to have this flexibility instead of putting sensors in remote places. We also have the possibility to use some sensors in order to detect problems in these places, toxic smokes, and also we can send a leader with 4 legs in order to do some biometric analysis of a specific point, and also having a digital twin, for example, for the building process. We can use these robots to do these gaugings and inventories as well. And also, we have something else, and the surveillance of critical spaces. So we can have robots that are controlled using these augmented surveillance with a thermal camera detecting people where they shouldn't be. And also, for example, if we have a central that receives alarms, we can send these robots in order to make decisions, in order to detect false alarms. And also, the combination of 5G robotics gives a lot of possibilities, but it is important that 5G is a key technology so that robots can react in real time to this changing environment that can be flexible, and also to prevent unpredicted aspects. And now we're going to see the demo. Thank you, Vanesa. So now we understand how the telecommunication networks evolve, and Vanesa talked about the cross-section capabilities, and in order to unblock the robotics of the future. Everything is theory now, but it's interesting to see the practice. In collaboration with Alice's partner of Boston Dynamics in Spain, in our internal Boston Telefónica, Alice's in the industrial sector, we are going to show you this electrical substation, as you can see here, and this internal part. And they require this surveillance, this intrusivism, and also they require some to prevent risks because of the high voltage, the overcharging. So this is the image that you can see with something physical related to reality. And I explained to you this electrical substation, this power substation have an internal part, an external and internal part, and also they require remote operation. And we see robotics as a complement to people. So robotics can save people from some risks. And here you can see a high voltage, these highly charged element, and there is a trigger that deactivates this, but we don't want to send a physical person because it's a risky operation. And now I'd like to give the floor to my colleague Vanesa. She's going to give you more details about the demo and also a sport enterprise from Boston Dynamic whenever you want. Now you can see it, the robot. He is a sport enterprise. As you can see, it is a quadruped robot, autonomous, with this articulated arm. And we are controlling it from Torre Diagonal. Our office is there in Barcelona. And we are using it to control it in order to achieve these coverage, these 5G coverage that we have here in the Telefónica stand. You can see David, who is controlling it remotely, just with a joystick. It's very easy. And also, Spot has a thermal camera, an infrared camera. This is the wide camera you can see at the back, and also a webcam and a 360 camera. So now you can see the flows at real time in the 5G network towards the control room, so that you can see it, the screens that David has, and the heat map from the thermal camera. Then to the right at the top, the 360 camera, and then below you can see the flow of the video from the internal cameras. To the right, you can see the profundity camera in order to do some gauging, and then to the left, you can see the camera at the end of the articulated arm. It's very important for these maneuvers it's gonna make. Now you're gonna see how it works in the power substation. So the control center is 15 kilometers away. And this articulated arm allows it to do some maneuvers, getting into the central. So now it's going to open the door. It is now calibrating with the camera, with also a profundity one. It is a high precision task. So Spot has overcome this first test with success. The operator is checking all the flows and then opens the door when everything is checked and supervised. And now Spot is accessing the interior of the central and collecting information with the different cameras. And now you can see the infrared camera focusing on this overheated element, this red ball, orangish, and there is something overheated, and we need to make a decision about it. We have to switch it off in a remote way, just with a spot, our hands and our eyes there in this further away location. High precision, the lever, the red lever is pretty small, so it requires a specific action when we check that the environment is secure and safe.
Un poquito a la izquierda.
Aunque veamos que tarda en ciertas ocasiones.
Well, it's taking its time, but it's important that when you make a decision, that it's safe and that the action is going to be done correctly, and also the execution. And also, let me mention that it would be an application case with some case studies we are analyzing, and in order to complete the portfolio of security measures using robots as drones for air security, and also using this type of four-legged quadruped robot for increased security.
Recordemos que son entornos.
It is an environment with a static electric, a high temperature. It's getting closer, it's going to do it. And you can see the camera in the robotic arm. And then we switch it off. Mission accomplished. A round of applause. So you have seen, and we have done this inspection. We found a problem. We've been able to solve it in a remote way. So thank you very much, Spot. It is a very interesting technology, and we are going to see it evolve in the following years. And we can open a Q&A session if you want. And I don't know if you want to ask something. Spot maybe wants to ask something. We give the floor to the audience in any case. Well, if there are no questions, you can get in touch with us anytime. Through the metaverse, you can ask us any questions and we will answer them. Thank you very much. We hope you liked it and that you had fun. Thank you for your time and good afternoon.
Vamos, Spot. Vámonos.